Hello, College Algebra. Before we get started in this first lesson, on this first chapter, I wanted to let you know that we'll be looking at equations and inequalities, and we'll be going in the whole first chapter. We'll be covering equations like linear, quadratic, rational, and radical equations, and it goes pretty fast, so keep up, please. Alright, so this first section we'll be looking at linear equations, and later on we'll be looking a little bit more into linear functions in a later chapter. But these are some equations, and first thing we're going to start out with is basic terminology of the equations, and then we're going to solve a few linear equation examples. And then we'll be looking at some things called identities, conditional equations, and contradictions. And then solving for a specified variable is the last thing we'll be looking at. And we'll be able to apply some of the knowledge from what we learned in a word problem. Okay. So some basic terminology here about equation. An equation is a statement that two expressions are equal. So here are three examples of equations that I have for you. You see that x plus 2 equals 9. That is known as a linear equation. This next one is also a linear equation. This last one we'll not be covering in this lesson, but a later lesson. It's a quadratic. And what this means is later on we'll be studying about degrees of different equations and functions, and that comes from the power, as I'm highlighting right now. But like I said, we'll study about these later in another section or chapter whenever we get to it. Okay, some more terminology. I'm just going to read here. It says to solve an equation means to find all numbers that make the equation a true statement. These numbers are the solutions or roots of the equation. So whenever you're asked to solve for x or solve for the variable, that's what you'll be solving for, the solutions or roots. These two words are interchangeable here. Sorry, there's the bell. A number that is a solution of an equation is said to satisfy the equation. So many times whenever you're asked to solve an equation, you'll be asked to find a solution or a root that satisfies the equation. Here's another statement here. Equations with the same solution set are equivalent equations. We'll learn about those too a little bit later. Addition and multiplication properties of equality. We've learned these before in previous algebra classes. For addition equality, properties of equality, this means we can add the same thing to both sides of the equation and nothing changes the equation. Just simply adding things or subtracting things to both sides of the equation. Same. The multiplication property of equality. And this means we're going to multiply numbers to both sides of the equation, the same number to both sides of the equation, or even this encompasses the division property too. So multiplication and division property of equality means we're multiplying or dividing numbers, the same number, from both sides of the equation, and we use these properties in solving our equations. Okay. A linear equation in one variable. That's what we're going to be dealing with the majority of the time is one variable equations, meaning this right here. We'll be seeing a single variable like x or y or z or something like that. These values, other letters that you see, a and b, they are going to be replaced with actual real numbers in our equations that we are solving. So let's look at an example. This right here in solving the linear equation, first things first, before we get started solving anything, trying to get x by itself, what we're going to do is distribute use that distributive property. So multiplying that -4 throughout the parentheses, that gives us a -12x plus a 20. And then there's nothing, well, on this side, what we're going to be distributing, it's like saying we have a -1 here in front of our parentheses. So let's distribute that -1 out. So copy down the 3. Then we have -8x minus 7. All right, now that we have no parentheses to deal with, we're going to be combining like terms. There's no like terms on the left side of this equation, but there are like terms on the right side of the equation, such as the 3 and the -7. So let's put those together. Just copy down the 8x, and then 3 minus 7 gives us -4. And now we're going to be using that addition property. So we're going to add this -4, or add the 4 to both sides. And then also we're going to add 12x to both sides. And when we do that, we end up with 24 equals 4x. And now, using our multiplication and division property, we're going to take that 4 here and get x by itself by dividing both sides by 4. So divide both sides by 4 gives us x equals 6. And there's our solution. And I noticed in the book, they'll be asking you to write, give the solution set. So here's how you're going to write a solution set whenever you end up with a single number. Just state solution set. And in set notation, meaning these brackets like this, put your number that you just found, what x is equal to. So there you go. So if there's an equation like a quadratic or a higher ordered polynomial equation, you may end up with more values for x than just a single number like this equation. And you'll put all of those numbers inside your brackets like you did with the 6. Next. Okay, and this is still a linear equation, even though it has a lot of fractions in it. There's no x values in the denominator, so this is still linear. What we're going to do here is we're going to find our least common denominator, and then multiply that least common denominator to everything in our equation. So, multiplying by that least common denominator, let's find it first. Our LCD is going to be, look at this value right here. We have a 10, 2, 5, and then another 5. To me, what I see is 2 times 5, that's 10. So our least common denominator here is going to be 10. Now multiply both sides of the equation by 10 and use our distributive property, so distribute that throughout, and then same thing goes here, distribute that 10, and that pretty much gets rid of any fractions that we have in this equation. So distributing the 10 on the right side of the equation will end up actually canceling that denominator out completely, so that we're left with 3x plus 6, and then this 10 right here to the 1/2 Well, 10 times a negative 1/2, that's going to give us a negative 5x. Okay, now moving to the right side of the equation. What we have here, distributing the 10 to the 2/5 x. Well, 10 times 2/5, that is going to give us 4x. And then the 10 times 33/5, that's going to give us 66. Now here we have a linear equation that we can more easily deal with. Just like before in the previous example I showed you, we're going to combine like terms. And on the left side of the equation, we have a 3x and the minus 5x to combine. That gives us a negative 2x plus 6. And there's nothing to combine on the right side of the equation. And then now we're going to use our addition properties. We're going to add or subtract the 4x over here. We're going to subtract 4x from both sides. And then we're also going to subtract this 6 from both sides of the equation. So that's the next step I do, which gives us a negative 6x equals 60. Now, dividing both sides, to get x by itself, we're going to divide by negative 6. And that gets our x by itself, and it equals, sorry, there's a negative there. That gives us a negative 10. And there we go. Our solution is x equals negative 10. So our solution set, if we're asked to find the solution set, again, we'll write that single number there in a set of brackets. Just like that. And that's our solution set. Okay. Alright. So, like I said, we're going to learn about identities, conditional equations, and contradictions. Here is what an identity is. An equation satisfied by every number that is meaningful replacement for the variable is an identity. What this means is what I have on one side of the equation is the same thing I have on the other side of the equation. And you can more easily see this if you distribute this 3 out right here. You'll see that if I distribute that 3, I end up with a 3x plus 3, which is the same thing as this side of the equation. So whenever you have the two sides are completely identical, then you have an identity. Okay? And in identities, one thing I want to state is the solution set is always going to be all real numbers. And we'll denote that all real numbers, the set notation of all real numbers, just like this with this funny looking R. Okay. Next one. Next we have is a conditional equation. A conditional equation is what you are used to solving in the ways of equations. Whenever you have a conditional equation, you have a solution for your x value. So just like this simple example here, if I were to divide both sides by those 2, I end up with x equals 2. And when you have your variable in your equation is equal to a number or a set of numbers, then this is known as a conditional equation. And you'll write a solution set just as we did in the previous few examples that we did. Last is an equation that has no solution is a contradiction. Just like this simple example I have here, if I were to solve for x, or try to solve for x here, what I would end up with is, well, let's subtract x from both sides of the equation. Alright, when I do that, I end up with 0 equals 1. Well, 0 does not equal 1, so that's a contradiction. Anytime you end up with two sides of an equation that contradict each other, just like this one here, there you go. It's known as a contradiction. Alright, so some examples on identities, conditional equations, and contradictions. Let's solve this equation and see what we end up with at the end. So first step, we're going to use that addition property. Let's subtract the 4x and add 9 to both sides of the equation and see what we get. So when we subtract the 4x, we end up with a 4, sorry, not 4. Let's erase that. We end up with a 2x equals, now add the 9 to both sides, 22. And now using our multiplication and division property, divide both sides by that 2, we end up with x equals 11. Well, since we actually ended up with the solution for x, this is known as a conditional equation. So state that we have a conditional equation this is a conditional equation. And then it's asking up here, it says give the solution set. So the solution set is what x is equal to, 11. There we have it. Another example of finding the identifying types of equations, just like before. Let's try to solve for our x value. So first things first, let's distribute, use our distributive property. And there's nothing to do on the left side of the equation, so just rewrite it. So on this right side of the equation, we end up with 14x minus 35. And let's do this next step here. I'm going to subtract 14x from both sides. And when I do that, what I end up with, I'm going to go ahead and write that step down. When I subtract 14x from both sides, it cancels it out from both sides of the equation. So what I end up with is a 10 equals negative 35. Which is not a true statement. Therefore, we have a contradiction. So this is a contradiction is what I'm going to state. Okay. And it asked us to give the solution set. Just because we did not end up with the solution set doesn't mean we do not write anything. What we're going to write for this solution set is something known as the empty set. You may or may not have seen this before in your algebra classes, but there's a couple of ways you can write this. You can write an empty set with this symbol here, or you can write it as this. In our set, as we did before, with a number, but with no number in it at all. This is also known as an empty set because there's nothing in our set here. Okay, next example. Alright, this is the last example. So far we've done an identity, we've done a conditional equation, we've done a contradiction. Next, this is more than likely going to be an identity. So let's look at it. Like I said before, use your distributive property first thing. And when we use our distributive property, let's see what we get. Okay, that's what I end up getting after my distributive property. And now, combine like terms on this left side equation, because I see a couple of terms that can combine. And we end up with 3 minus x, because a negative 6x plus 5x gives me a negative x. And we have the same thing on both sides of the equation. So since we have the same thing on both sides of the equation, like I stated before, this is an identity. And the solution set, like I stated before, anytime you have an identity, is the set of all real numbers. So solution set. And how we're going to state the solution set is just like that right there with that symbol. Okay, so the last thing that we're going to discuss in this section is solving for specified variables. And you're going to often end up, like in your homework problems that I'll assign you, you'll have formulas such as this one here. And what you'll be asked to do is solve for a specified variable. So I could ask you to solve for P or solve for R or T in this equation here that is stated. But also in the last example, before we move away from this slide, I want to state that we'll be using this formula here in the word problem that I have for you in the last slide. So let's look at this formula real quick. In this simple interest formula, I is known as the variable for simple interest, and P is is known as the principal. And this value is often going to be stated in a number of dollars. R is our rate, and you'll often find this by a number in the word problem followed by a percent symbol. And then T is a variable. It's measured in time, but it won't state in the problem. Sometimes it'll state months or days or something, but you have to convert those months or days to years for this particular formula. So let's move on to solving for specified variables. Okay, in this first one, it's pretty simple. This is our distance formula. Distance is equal to rate times time, and we're asked to solve for t. So let's do it. The only thing we need to do to solve for t is let's divide both sides by r, and that's going to get t all by itself. So we end up with t is equal to dr. See? Pretty simple. This next one, not as simple as the first one, but it's still doable. I know y'all can do it. So let's look at it. We're asked to solve for k. So what we're going to do, as you can see in this equation, we have k in two different terms of the equation. We have a k here, a kr squared, then we have a krl. And how we're going to do this one to get k by itself, we're going to factor out a k. That would be my first step. So taking out a k, when we factor, the rest of it goes in parentheses. So when we factor out a k from this first term, we're left with r squared. So write that down. And then this next term, when we factor out a k, we are left with just the r and the l. So write that down, r, l. Now that we've combined our k terms together by factoring it out from these two different terms that we had before, I hope that y'all can see what our next step is going to be to get k all by itself. It's just like example A. To get t by itself, we divided both sides by the r. So in this step, what we're going to do is divide both sides by, because this is k times this whole thing in parentheses, divide everything by what's in this set of parentheses. So again, do it to the other side also. Okay, so we have, once we divide both sides, that completely cancels out, and we're left with k all by itself. So k is equal to our s over r squared plus r l. And that is our solution. Last example for this right here, for this type of solving for specified variables, is this right here. Just like all other equations, our first step was to distribute, use our distributive property. So let's do it first. And then we'll look at what we are solving for. So we have 8y plus 10w minus 6z. We're solving for y here. So we have a y on both sides of our equation. We have 11y here and an 8y here. So combine the two of them. Simply subtract 8y from both sides, and we have our y's put together. And whenever we subtract the 8y from both sides, we end up with the 3y plus 8 is equal to 10w minus 6z. Now to get y all by itself on the left side here, let's subtract 8. And then, again, still trying to get y by itself, divide both sides by 3. And when we divide both sides by 3, we end up with this right here. And we are done. Okay. Our last example is a word problem. And I told you, like I said, we're gonna be using this formula here, simple interest formula. I'm gonna go through this word problem, read it, and underline the things that matter to us most. Okay. So Jared North borrowed $2,580 to buy a new kitchen appliance for his home. He will pay off the loan in 9 months at an annual simple interest rate, annual matters here, of 6%. How much interest will he pay? So I is the amount of interest he will pay. That's what we are solving for. And we are given everything else that we need to solve for that value. the principal, like I said before, that is going to be in dollar amount. So that's this up here. That's the amount of money he borrowed. And then our rate, told you it's going to be followed by a percent symbol, so that's this 6% right here. But in our formula, we need to put it in decimal numbers. So go ahead, write it out. R is equal to 0.06. And then I underlined annual to just let y'all know that that really matters, because right now our time here is being measured in months, but it's an annual simple interest. So what we're going to do here to get our time in the amount of years that we're looking for is just take our 9 months, and how many months are in a year are 12. So we're going to say 9 divided by 12. So our time in years is 3/4. Okay? So now that you got your P, your R, and your T, solve for I. And let's see, 3/4. Plug away into your calculator, and you end up with your interest that will be paid back is in a dollar amount. So don't forget to put dollars. And in all dollar amounts, I only want you to round to the nearest 2 decimal places, so the nearest cent. This is what I end up getting. So, in interest, we will pay, or Jared will pay $116.10. And that is it for this first section. I'll see you next time.